Okay, so in this question it says a pebble is projected vertically upwards with a speed of 10.5 meters per second, okay, from point A at the top of a cliff. So you can see here at the top of my cliff, it's gone upwards. So because it's gone upwards, we'll take upwards as positive, right? And of course, acceleration caused by gravity is always downwards, okay? That's opposite direction to our positive in this case. So part A then, it says find the greatest height above A reached by the pebble. So we know U is 10.5, all right? And we know A is minus 9.8, okay, because it's going opposing the positive direction. Now, at greatest height, of course, as we saw in the last question, velocity is 0, isn't it? Okay, velocity is 0. So we can use v squared equals u squared plus 2as. And we can find the greatest height, okay? Because we've seen, logically speaking, the ball will slow down, the pebble will slow down as it gets towards its max height. And then when it gets to its max height, this final velocity will be 0. So 0 squared equals 10.5 squared plus 2 times minus 9.8 times s, okay? So then we'll work those numbers out, and I'll calculate the 10.5 squared is 110.25 minus 19.6 s, okay? Take that over to the other side, so we get 19.6 s equals 110.25, and then s will equal 110.25 divided by 19.6, and we get our answer, which is 5.625 meters. Okay, and that's an exact answer, so I'll leave that like that, right? I won't round it. We've got our answer there perfectly defined. Okay, so that's the greatest height. Now part C says, okay, or part B says, sorry, the pebble reached the bottom of the cliff 5 seconds after being projected. Calculate the height of the cliff. So basically, we want to know what S is, okay, because it's talking about height. We want to know what the S is when T equals to 5 seconds, yeah? That's what it says, 5 seconds after it being projected. Now, I know once it's projected, it goes up, doesn't it? And then it reaches its max height and then falls, and it's going to go past the starting point and going to go to the bottom of the cliff, okay? But we can treat this all as one system, okay? So our equations are set up. We're still going to take upwards as positive, okay? Even though the pebble will be going downwards, right, in terms of what we're interested in, you always go with what we started with. And when we started this, it was projected upwards. So we're taking upwards as positive. Gravity then opposes our positive direction, so that's going to be negative. And we're going to fill in the details then to see if we can work out what S is. So T is going to be 5. Remember now U, of course, we know is 10.5. A then is minus 9.8, of course, yeah? So I think here we can use S equals UT plus half AT squared, okay? So we can just chuck the numbers in. S equals 10.5 times time, which is 5, plus half times minus 9.8 for acceleration, times then T squared, which is 5 squared. So I'm going to work this out all in one go on my calculator. And I get minus 70 out, okay? Minus 70, exactly. And that might sort of, you might think, well, that's weird. How can you have a height of minus 70? Okay, I might have done something wrong, but not at all, right? You've done nothing wrong. If you have a minus out, that's fine, because remember, S is representing displacement, okay? It's not talking about distance, all right? And you can have negative displacement based on your starting position, okay? Now, if we think about it, we started here, didn't we, at A, and we took upwards as positive, okay? So it reaches its max height, and then it falls down, but then it goes the other direction, doesn't it? It's going the other direction. Now upwards is positive, which means then this way then is going to be negative numbers. Because if it's 0 there, and you're increasing positive here, you can have minus here in terms of displacement. So you can end up down here and it's saying then that's minus 70 in terms of displacement. So then we can say quite simply the height of the cliff is 70 meters. Okay, we write obviously then the positive 70 because we're interested in the distance, right? Even though this is displacement, we actually want the distance, the height, which we get from our answer here.